My name is Po Chen. In this video we'll talk about how to build your own clusters from several desktop computers running the Ubuntu Linux operating system. So in this video we'll talk about first how to set up a local area network by using a wireless router and several desktop computers. We'll talk about how to set up the host names uh, for those desktop computers. And then we'll talk about how to set up the secure shell or SSH so that you can log in to the different nodes on your cluster. And then we'll talk about how to set up the network file system NFS so that the different desktop computers or different nodes can access the same file system. And then we'll talk about how to install compilers and the message passing library. And we'll end with some testing, and you guys will see how to run parallel computer programs on your new cluster. And let's get started. So in this particular example, we'll be using two desktop computers, and one as the master node and the other as the slave node. And so let's take a look at the information about one of the desktops, the one that I'm using right now. And I'll click here and about this computer. And it's displaying some of the basic information about this particular desktop I'm using. It's running a Ubuntu 14.04 long-term support. It's a particular branch of the Linux operating system, and in a later video we'll talk about the details of the Linux operating system. And this computer has a name, Fresnel, and I'll show you later how to actually configure the hostname for the desktop. It has some memory. It's using a AMD 8-core processor, and it has a GeForce video card. The operating system is 64-bit and has some disk space. Right. And this device name, this particular name for the desktop, has utilities when we try to set up the host names for the different machines on your network. And if you want to sort of take a look at where you get this host name, you can open a terminal. So I'll right click new terminal, and you can take a look at the content of this particular file that's called etc host names. And it has just one line of text in this particular file. It's called Fresnel, and that's the name of your machine. And if you want to change this name to any other name, you can just do sudo using an editor. It's going to ask you to enter your password, and you can edit this host name. And this particular desktop is actually connected to a wireless network at my home, and you can actually find out information about this local area network by clicking here, and then you can just find out the information. Right. The network name is called Lavender, and it has some information about the network card that's on this desktop and its IP address. We'll look at the details of this kind of information later on. And the most important thing you have to make sure is that you have a login, you have an account on every desktop in your network. So if you want to sort of take a look at the account information, you can click here. It's gonna bring up the system settings application, and it's gonna give you a user accounts, and I click on it, and it's gonna display the information about my particular account. So you have to make sure that you have an account on every desktop you're gonna use in your cluster. Right. And this is one of the computers, Fresnel. that's we're gonna use this Fresnel as our master node, and we'll get another desktop. Um, and this particular desktop is located at a different location, but it's connected to the same network. And I'll try to show you some basic information about this other computer. And so this is the machine information about the other computer that I will be using as the slave node, right? And it has a name that's called Gauss. It's running the same operating system, has some memory. Processor type is an Intel Core i5, and it's got a graphic card that's Intel Ivy Bridge, and has some disk space. And this is the network. It's using the same Lavender. It's connected to the same Lavender wireless network. It has some basic information about the network card on that particular machine, and it has some IP address information. And I also have an account on Gauss, and this is my account name. It's exactly the same as the account name on Fresnel, my master node. Right? And basically that's all you need in order to actually use the two computers to set up your cluster. So in order to connect all the computers together, you will need a local area network. And you can actually do that by using a router. Here's a picture of the router. That's the white box on the left. And a modem. That's the black box on the right, and it is provided by the cable company. And what you want to do is to connect your router with the modem. So this is actually the back of my router, and you want to connect the WAN port, WAN port, with an output port from the modem. And here's the power cable. Here's the on-off switch, and you have 4 different Ethernet ports. You can also connect Ethernet cables to this router, and it's a TP-Link wireless router. And so after you have connected your router with your modem, you can open a web page, try to set up your router. And this is again on my desktop. That's a Fresnel, and what you have to do is to enter this particular sequence of IP numbers, 192.168.0.1. And once you actually have loaded this page, you're gonna be presented with setup page for configuring this particular router. And what you want to do is to click on the quick setup, and it's going to take you through all the different steps in order to set up the router correctly. If you are using a different router, it could be a different kind of process and different kind of web page. But usually the address that you want to enter into your browser of your desktop is what they call the default gateway, and it's a address that you can find usually on the status page. If you click on the status link, it's gonna give you for LAN, your local area network. It's gonna show you the MAC address. I'll talk about the MAC address a little bit later. The IP address and the subnet mask. These 3 numbers are actually for your router. So this is actually the router's MAC address, and then this is the router's IP address on your local area network. And you actually have to sort of enter this IP address into your browser in order to get to the setup page. But what I'm going to show you is the DHCP. The DHCP. If you click on DHCP, it's going to show you some menu items. We'll go to the client list, DHCP client list, and it's gonna show you client name and then MAC address. So at the current stage, I have 1, 2, 3, 4. I have 4 different computers that's connected to my local area network, and they have different names. We looked at Fresnel. We also looked at Gauss. We also have 2 more computers that's attached to the same network. One is called Count, and the other one is called Hilbert. And you can connect as many computers to the network as you want, and all of those computers can be sort of added to your cluster and for parallel computing later on. So on this column you have the MAC address. The MAC address is called the media access control address. It's a sequence of numbers and letters that's unique to every network card. So every computer that has a network card is gonna get a MAC address. Usually you can find the MAC address by using a terminal. I can type ifconfig, and it's gonna show you what's actually the MAC address for Fresnel, the one that I'm actually using. So you can actually compare it with the DHCP client list. It's exactly the same sequence of numbers and letters also. It's another thing that we want to do is to reserve the IP address for the different machines that's connected to our local area network. So if we click on address reservation, you're going to see on the left hand side you have MAC address. That's a sequence of MAC addresses for the different devices that's connected to your local area network. And on the right hand, it's the reserved IP addresses for each of the different devices. So DHCP actually means the Dynamic Host Configuring Protocol. It's a protocol that allows a network server to automatically assign an IP address to a computer from a defined range of IP addresses. So it's actually possible the same machine will get different IP addresses every time it connects to this local area network. But that's not exactly what we wanted. What we want is for a machine to have the same IP address every time it connects to the local area network. So what we want to do is to reserve a specific IP for a specific MAC address. So the first MAC address is actually for Fresnel, and I have a reserved IP address that's assigned to it. It's 192.168.0.105. So you can add as many address reservations as you want by using this add new button. Here you can enter the MAC address of the specific computer that you want to reserve an address for, and then you can enter the specific IP address you want. So every time Fresnel gets connected to the Lavender network, it's gonna get a fixed IP. And you can see this is actually the network name, Lavender. And back in the terminal, when I did the ifconfig, it's gonna show you what's actually the IP address that's gonna be used for Fresnel. And this IP address is 192.168.0.105, and you can compare it with the address reservation. It's exactly the same actually, right? So after we have finished configuring our local area network, we will need to install the SSH server on every machine that we are going to use in our cluster. And SSH is the secure shell, and it's actually a quite safe way for you to actually log in to a remote machine and manipulate things. So it's encrypted, and it's just like Telnet but with added security. So in order to install the SSH server on Ubuntu, all we have to do is to open a terminal and then type the following command. So we do sudo apt-get install open SSH server, and it's gonna ask me for my password, and then I'll just install it, because the SSH server is already installed on Fresnel, so it's not installing anything else, and it's just telling me it's already the latest version. And then SSH is now installed. So if you want to check to make sure that it's installed correctly, what you can do is to take a look at if the SSHD is actually running. So you can do this ps -A and then pipe grep SSHD. So I see one line as the output. It's telling me that SSHD is actually running. So we can do more checking. We can find out if the server is actually listening to the right port by doing the following command: sudo ss-lmp pipe grep SSHD. So it's actually telling me that it's listening to the port 22, and this line is actually for IPv6. So so it's actually listening to the right ports. If your output is different from this one, then there might be some problems, and we have to sort of figure out how to fix them before we actually continue. So the last test you can do is to log in to the machine that's the machine that you are using. So if you want to do that, you can do ssh-v localhost. Localhost means the machine that you're actually using. So it's gonna ask you for the password to Fresnel, and then after it prints out some information, it's gonna just display a prompt asking you to type in some commands. So if you get to this particular prompt, that means that you have successfully installed SSH and you want to exit now. So I typed in lots of shell commands, and we'll talk about how to use those shell commands, how to use the terminal in general in a later video. But for now, all we have to do is to make sure that SSH is correctly installed on both the current machine that I'm using, which is Fresnel, and also every other machine that we're going to use in our cluster. So basically we have to repeat exactly the same process on those different machines, like Gauss, right? So what I'm going to do is to go to the other machine, Gauss, and to repeat the same steps, but it's not going to be recorded. After you have installed SSH server on every machine in your cluster, you can try to log into them from a master node. And at this stage, you will need the IP address for every machine in your cluster. So one way of finding out the IP address for different machines is just by looking at your router configuration page. So here again, I'm looking at the DHCP menu item, and I'm at the DHCP clients list. So here I can see all my machine's name and their corresponding MAC address. So I have my Fresnel, that's my master node. It has a machine address, the MAC address. And then Gauss, it has another MAC address, 7CDD 90, 82, 87, and 2E. And then I can just go to my address reservation page. And look for the same address for Gauss, for example, right? And the Gauss has a MAC address that's 7CDD 90, 82, 87, 2E. In my case, it's just the second one from the top. And the reserved IP address for Gauss is then 192, 168, 0, and 107. So this way I can find out the MAC the IP address for Gauss. If I want to try to log in to Gauss, I can use this IP address. A second way of finding out the IP address for Gauss is by looking at the 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 network connection information on Gauss actually. So I'm here on Fresnel, but I can click the same position on Gauss and then connection information, and then it's gonna give me the IP address. So this is actually the IP address for Fresnel, right? If I do the same thing on Gauss at this particular location, it's gonna give me the address for Gauss. That's a second way of doing to find out the IP address for a different machine. And there's a third way. A third way for doing that is just by opening a new terminal and then type ifconfig. And again, I'm on Fresnel, so it's displaying the IP address for Fresnel. But if I'm doing the same kind of thing on Gauss, it's going to display the IP address for Gauss. So once we have found out the IP address for Gauss, you can actually remotely log in to Gauss from, for example, Fresnel. So now I am in a terminal window on Fresnel, and I want to log in to Gauss from Fresnel. So what I'm going to do is to type SSH, my username, at the IP address of Gauss, which is and it's saying something about the authentication. So I'll type yes, and then it's asking me for the password on Gauss. So I'll just type in my password on Gauss. So now I am on Gauss. So if I want to list the content of my home directory on Gauss, it's just do ls, and I can see everything, and I can manipulate everything. Right. So if you are done doing your stuff on Gauss, you can exit by typing exit exit, and now you're back to Fresnel. Right. But the thing about SSH is that it's going to ask you for a password every time you try to log into a remote machine, and this won't be feasible if you are trying to run some parallel computer programs on multiple machines, because it won't be feasible for you to actually type the password manually every time you log into a remote node. So what we want to do is to set up a passwordless login for your SSH, and the command for doing that is called SSH keygen. So SSH-keygen, and this command is going to generate two keys, one private key and one public key. And what we want to do is to copy this public key to every other machine that we want to use in our cluster. So we will do SSH keygen -t RSA, and then it's gonna ask me which file I want to use to save my private key. So my private key is going to be saved under inside of this particular file that's called id_rsa, and this file is inside of a directory that's called .ssh on my home directory. So I'll just accept the default file name, and then it's going to ask me for a passphrase. So we want a passwordless login, so we'll leave passphrase empty just by typing enter, and then it's going to ask me to type the same passphrase again, enter again. And then if you look into .ssh, you're going to get two files. One is called id_rsa, which is your private key, and then there's another file that's id_rsa.pub. It's your public key. Now you want to give your public key to every other machine that you want to log into. So the command for doing that is called ssh-copy-id, and then all you have to do is to give it the account name on the remote machine at IP address of the remote machine for Gauss. It's and then it's gonna ask me for the password on Gauss. And then we're done. We have finished copying the public key to Gauss. So now if I want to log in to Gauss still by using SSH, so it's not asking me to enter any password anymore. It's if you want to do LS, that's listing all the content, right? If you want to go into a specific directory, you can sort of do that. And if you want to exit Gauss, you can type exit. And if you want to log into Fresnel from Gauss, what you can do is to generate the two keys, the public and private key pairs on Gauss, and then give the public key of Gauss to Fresnel. And then if you want to log into Fresnel from Gauss, you can just type SSH followed by the IP address of Fresnel, and then SSH is not going to ask you for a password anymore. And you can actually repeat the same process on every computer that you are going to use in your cluster. So this way you will be able to log into every other node from one node without any password. The IP address is actually quite cumbersome to use. It's a very long sequence of numbers that you have to memorize and type every time you have to log into a remote machine, and it's very easy to make mistakes. So what you want to do is to set up a kind of a shorter name, easy to remember name for each of the different machines. And you can do that by modifying a particular file on your system. And this file is called it's stored under the etc directory, and it's called hosts. And this file is just a text file that can be edited, and you can use your favorite editor to change it. So if I want to use because this is a file that's controlled by the system, so you have to use the sudo in order to edit it, to make changes to it. I'm going to use Emacs as my editor, and just type enter. It's going to ask me for my password, and you can see that this particular file is just a lookup table, and on the left hand side it's the IP address for the different machines, and on the right hand side it's the shorter name that you gave to every machine. And you can sort of see that's Fresnel. We have an IP that's 105, right? And then you have a Gauss that has an IP 107, and we also have several other machines that has IP addresses. And the first line is called localhost. This line was already existing in the file when I started editing it. So this line was generated by the operating system itself, so I don't want to change it. You just leave it as it is. And the lines that start with the pound sign are comment lines. Those are lines that's going to be ignored by the system. And so every time if you want to use an IP address, now you can use an alias for that particular IP address. Suppose if I want to log into to this particular IP address, now I can just type Gauss in place of this very long IP address. And now you can see the importance of having a reserved IP address, because every time if my IP address actually changes, I have to actually go back to edit this particular file if I want to keep using those alias for login. So if we fix the IP, if we reserve the IP in our router setup page to a fixed number, and then this file is going to be fixed. I will never need to change it if I want to use those aliases. And you have to sort of keep a copy of this particular file on every machine in your cluster. So on Gauss there will be an identical file with the same lookup tables. And on Hilbert, Cauchy, Newton, or every other machine that I'm going to use in my cluster, you will have an identical file. And so once I have generated this particular file, I can just log in to Gauss by just typing Gauss. If I have an account name on Gauss, I use poaching @Gauss, and then I can get into Gauss without using the IP address. So now I am on Gauss. If I want to look at the same file, I can just do cat etc hosts, and it's going to display exactly the same lookup table, and that's identical to the lookup table on Fresnel actually. So if I want to exit Gauss now, I'll just type exit. So now the different computers in our network have been fully connected, and we can access one machine from the other machine by using SSH. So if I have two terminals on Fresnel, so if I use the right terminal to access Gauss by using SSH, I can just type SSH Gauss, and now I am in Gauss. But the different computers are still independent. Each computer has its own file system. If on Gauss, if I do ls, you can see it's a set of directories, and this set of directories is actually quite different from Fresnel. So each machine has its own file system. But when we try to run a parallel computer program on multiple machines, those machines must have access to the same computer program. They must have access to the same input and output files used by that computer program. So, which means that we will need a common file system that's shared by all the machines we're using as computing nodes. We can construct such a common file system by using what we call the network file system, or NFS, and we must install NFS on the master node and also on the different computer nodes. So on the master node, which is in our example, it's a Fresnel. On the master node, we have to install the server version of the NFS package, and we can install it by typing sudo apt-get install NFS server. Slave nodes, we must install the NFS client version, and what we can do is to do sudo apt-get install NFS client. So if we have multiple slave nodes, we must install the NFS client on every slave node by repeating the the command that I just typed, which is this particular command. We have to install the NFS client on every slave node by just SSH into that slave node and typing this command. There are shortcuts that allows us to just type this command once, and every slave node will have NFS client installed, and we'll talk about those shortcuts later. Now, after we have installed the server and the client, we have to make a directory. That directory are going to be shared among all the different computers, and we can do that by again using sudo. So I'll switch to the root directory on my master node, and I can do an ls. You can see there are lots of directories that's already mounted under my root directory. So what I'm going to do is I'll make a new directory. I'll just do sudo mkdir. I'll just call it nfs, and this will be our shared file system. Right? And you can see there's a nfs directory, and if I do ls nfs, there should be nothing in it. And the next thing that we want to do is to export this file system. In order to export this file system, we have to edit a text file. That's this particular file. It's etc exports. Actually, it's etc exports. And it's also a text file. If we want to look at the content of this particular text file, we can just do a cat. So what I was telling you before, every line that starts with a pound sign is actually a comment line. It's going to be ignored by the system. For now, every line in this particular file is a comment line. So this file is effectively empty. But now we have to add one line. Add one line to export the directory that we just created, which is called nfs. And we can do that by using an editor. We'll do sudo vi etc exports, and we will need to insert a line. So now if you take a look at the content of this particular file, it will have one effective line, which is this line that we just added. So now we can actually start the NFS server, and we'll restart the NFS server actually. So we'll do sudo service nfs kernel server restart. And then on the client side, we will have to mount this NFS directory that's actually residing on the master node for now. But after we have mounted this NFS directory on the client node, on the slave node, we will be able to access this file system on the slave nodes. So the way to do that is again by editing a specific file that's called etc fstab. And again, you can look at the content of this particular file by just doing cat fstab. So for now, it has certain some lines that's in it. It's basically mounting the different partitions of the hard disk. So we'll add a new line to it, and we can do that by using our editor. We're just going to use Emacs on the client node. So all the lines that's starting with the pound sign is a comment line, and it's in red. So these lines are going to be ignored by the system, but these yellow lines are actually useful. These lines are actually for different partitions of the hard disk on the client node or on the slave node, and we're going to add one more line. So the line that we're going to add is like this: Fresnel : and NFS, and then we can just exit the editor. So after we have finished editing this particular file, we can actually mount all the partitions. We can remount all the partitions. Oh, I'm getting an error message because I did not create a directory that's on the client on the slave node. I must sort of recreate the same directory on the slave node first. So I'll do sudo mkdir nfs. So this way I have created the same directory on my slave node, and then I can mount all the partitions. Now if I look into the NFS directory, there's nothing in it yet, right? But after we have created some files on the master node, those files will automatically be mirrored to the slave nodes. So now we have created a common file system on both the master node and also all the slave nodes, and this directory is called NFS. So now let's try to generate some files into this particular directory. And before we do that, let's take a look at what's actually the permission for this network file system NFS. I can do ls ld NFS, and it's telling me that the owner of this particular file system is root. But most of the time we are actually running parallel computer programs not as a root user but as a normal user. So in this case the normal user has a username that's Pochen. So what I want to do is to change the owner of this particular NFS file system to Pochen. So what I'm going to do is to do sudo ch owner Pochen NFS. Now if I do ls ld NFS, it's showing me that the owner of this directory is actually Pochen now. So now let's try to create a text file inside of NFS. We'll call this text file machine files. So we'll just do vi. We'll just use an editor vi NFS machine files. We'll call it machine files. And we're going to type Fresnel colon 8. The 8 is actually the core number for the master node because I have 8 cores on Fresnel. So I'll just type Fresnel colon 8. And on Gauss I have 4 cores. So I do Gauss 4. So after I have finished writing the text, I'll just quit. So now we have one file inside of the NFS directory, and you can look at the content of this particular file. It has just 2 lines. One is Fresnel 8, the other one is Gauss 4. And if you go to the Gauss, the slave node Gauss, you can see exactly the same file. So if you go to So you can take a look at the content of this particular file by just doing a get. Right, exactly the same content. So now we have to create some computer programs that can be run on multiple machines, and we're going to use a C language. So we're going to write a C language program and try to compile it. In order to compile a C language program, we will need a compiler. So if you don't have the compiler installed already, we have to install it. So on the master node, we will do sudo apt-get install build essential. So this build essential package actually contains the C compiler. So it's actually telling me I have this package installed already, so I don't really need to reinstall it. But if you don't have this package installed already, it's gonna install it and all the dependencies. So if you want to sort of take a look at my GNU GNU compiler for C, that's GCC, it should be installed already. You don't have to install the same thing on all the slave nodes if you have all the libraries that's already installed. But if you want to install those compilers, you can just repeat the same compiler, the same command. So what you have to do is sudo apt-get install build essential. And if you run this thing on the, if you run this command on the slave node, it's gonna download and install all the compilers on the client node also. So if you do which GCC, it's gonna tell you it's installed. So once you have the compiler, you also need a message passing interface library, or MPI library. The message passing interface is a library that allows you to communicate among the different machines in your cluster. So there are different flavors of the MPI library. The one that we are going to use is called mpich2, and again you can install it by just using sudo apt-get install mpich2, and this package must be installed on both the client node and also the on both the master node and also the client node. So after you have finished installing both the compiler and the MPI library, we can start to edit a C program, and we're going to create one that's called MPI hello.c. So I'll just we'll talk about how to write C programs and how to write MPI programs in different videos. But for now, let's just write a very short, very simple computer program that's gonna print out something. Size. And that's our C program. And we can take a look at the content of this C program. And the same C program should also exist on the slave node. So if you do cat MPI, and now we have to compile it. If we want to compile it with the MPI library automatically linked with your C program, we can use MPICC. And MPICC is sort of the binding of MPIC2 with the GCC. So I'll do MPICC MPI hello MPI hello.c, and this way we're gonna get a executable that's called MPI_hello, and we should be able to get the same executable on the slave nodes also. It should be MPI hello. So now we can actually just run this code. We can run this code by just issuing MPI run MP. So we have 8 core on the master node, which is Fresnel, and we also have 4 core on the slave node Gauss. So totally we have 12 cores. So the number of core we're going to use is the number of MPI process we're going to use is 12, and then we will need to specify a list of the machines that we'll use for this calculation. And this particular file is called a machine file that we just created. And then we can just run MPI hello. So it's going to print out both the rank and the total number of process on the for this particular run. We have 12 MPI process, and this is rank 0. It's printing out hello from rank 0, and then rank 1, rank 2. You can see they are not ordered in a specific way. This is because the different print is actually generating in a random order, and they are all sort of printed out in a random order. So there's no way you can sort of tell which one is going to print first. The reason that it looks like the program is hanging is because I put a infinite loop into the C program. And if you want to sort of look at where the infinite loop actually is, it's here. It's a while 1, and then so 1 in C language, 1 actually means true. So this while will always be true. So it's just gonna keep looping indefinitely unless we actually force it to quit. The reason that I put a infinite loop into the program is that I want to show you that this computer program is actually running not only on the master node, but also on the slave node. So if I go to the slave node, which is Gauss, I can do a top. So top is going to list the computer programs that's occupying most of the CPU time. So I should see 4 different copies of MPI hello on the slave node, because I launched 4 different MPI processes. So the machine file, if we look at the content of the machine file, I'm telling MPI to launch 8 MPI processes on Fresnel and launch 4 different processes on Gauss. So that's why I see 4 different versions of MPI hello on Gauss. But if I actually go back to Fresnel, if I sort of SSH to Fresnel from Gauss and do top, I should see 8 different copies of MPI hello. 1, 2, 3, 4, 5, 6, 7, 8. That's exactly 8 copies, right? So if I want to exit this particular parallel program, I can just type Ctrl C in the master node, and then it's stopped. So this concludes our first session on parallel programming, and we talked about how to set up a local area network, how to connect all the different machines inside of this local area network, we talked about how to install and access different machines remotely by using SSH, and we talked about how to set up the network file system, how to install compilers and the MPI library, and we did a test run by using MPI Hello. And this particular video involves lots of details that we haven't covered so far, so the details about how to use the Linux operating system, how to actually use the shell, how to actually write shell scripts, how to write C++ programs, and how to write MPI programs will be covered in future videos. Thank you for listening. Thank you for watching.